So my symbols got distorted when it came into OneNote, but let's go through the do now. Given angle STE is represented by x squared plus 156 degrees, and angle STR is represented by 5x degrees. What is the most important thing we do with our given information? Chase. Label it in our diagram. So let's go ahead and label our diagram. So now follow the letters. Angle S to T to E, that is represented by x squared plus 156 degrees. And then angle STR is represented by 5x degrees. Okay. Now we're asked, is angle STR a right angle? Can I assume angle STR is a right angle? I see you all shaking your heads no. Good. We are not allowed to assume that angle STR is a right angle. Can I say that 5x equals 90? Can I do that? How many people say yes? How many people say no? Good. That's the same as saying angle STR is a right angle, right? We cannot do that. All right. Can I say that x squared plus 156 equals 5x? Can we assume that they're equal to each other? Good. A lot of people shaking their heads no. We cannot assume any of that, because can we assume congruent angles? No, we cannot assume congruent angles. What is the only thing we can assume? Straight angles. Do we all see that angle ETR is a straight angle? And we can assume that. So with that said, can somebody think of an equation to help us solve for x? Adam.
X squared plus 156 plus 5x equals 180.
Excellent. X squared plus 156 plus 5x is equal to 180. Now, I know we have to factor this. Can someone tell me, how do I know just by glancing at this that this will most likely be a factoring problem? Bridget? Good, because x is squared. So in order to factor this, I'm going to tell you right now, this is not a good format. So what's one thing we have to do to make it a good format? Connor?
Move the 5x in the place of 1.
Excellent. We need to put it in descending order. So we're going to put the 5x in the middle. So x squared plus 5x plus 156 equals 180. This is still not perfect. There's one more thing we need to do before we can factor. James? Excellent. We need it set equal to 0, so we're going to subtract the 180 on both sides. So we will now have x squared plus 5x minus 24 equals 0. And now I set up my double set of parentheses. So we have an x and an x. We need two numbers that multiply to negative 24 but add to a positive 5. Jocelyn? You got it. X plus 8 times the quantity of x minus 3. Are my answers 8 and negative 3? No. Now we need to take this a step further and set each parenthesis equal to 0. And now we would subtract 8 on both sides so we can get x is equal to negative 8. Here we would add 3 on both sides and get x is equal to 3. You tell me, am I allowed to have a negative x? Yes, you are absolutely allowed to have a negative x. What are you not allowed to have? James? A negative angle when you plug in. So negative x's are okay, but if that negative x leads to a negative angle, then that's not okay. Sometimes you'll plug in that negative x and you'll get a positive angle. That's why I'm telling you this. So we're going to take that negative 8. I'm going to plug it in for 5x. Well, 5 times negative 8, isn't that a negative 40? Is that acceptable? No. That is why we are rejecting the negative 8. So our only answer for x is equal to 3. Now let's go back. It's asking us, is angle STR a right angle? Well, how will I know? Sophie? You got it. We need to plug in x. So 5 times 3 is 15. So angle STR is 15 degrees. Does it look like a 15-degree angle? No. Is that okay? Good. Why? Why is that okay? Noah? Excellent. No diagram is drawn to scale, and we cannot assume they're drawn to scale. So is angle STR a right angle? We're going to write angle STR is not a right angle. It has a measure of 15. Yeah. All right, we ready? All right, so we are starting proof writing. We will be writing proofs until the springtime. So we are going to spend a decent part of the year in proofs. So we really want to make sure we have a solid foundation, because every single thing builds on this foundation that we're starting today. So the kinds of proofs we're going to be writing in class are called two-column proofs. And two-column proofs are literally two columns. One column is labeled statements. The other column is labeled reasons. Now, every single statement has to have a corresponding reason to justify it. So let me show you some things I want and what I don't want. So I will allow us to write S and R. Instead of statements and reasons, we could shortcut it to S and R. Now, we need to number all of our statements and all of our reasons. So let's say statement 1 was really long, okay? Let's say statement 1 was really long. And let's say reason 1 was really short. That's fine. What I don't want to see is statement 2 down here and reason 2 all the way up here. It's going to get really confusing for me, especially as we get into longer proofs if the statements and reasons don't line up. So what do I need from you? I need you to have statement 1 corresponding reason 1. Then I need you to draw a line sort of boxing it off, saying these two go together, that's its designated area. Then statement 2, reason 2, both numbered. And then what do you think I'm going to ask you to do again? Draw a line to box it off, and so on. That will really help me. If you have messy handwriting, I know that's not on you, but please try your best to be neat, because we will be doing a lot of writing in geometry, so try your best to keep it neat. All right, other things about two-column proofs. The very, very first statement is always going to be your given information. Your very first statement will always be your given information. Other things, in your textbook, you'll see the word conclusion sometimes. I'm highlighting it here. The word conclusion is the same as prove. It means they want you to prove it. Okay, conclusion is the same as prove. It means they want you to prove it. All right, every single statement has to have a corresponding reason. And if you really understand this next thing I'm telling you, it will make your life a lot easier. Well, in doing geometry, I guess. It'll make your geometry life a lot easier. So every reason has to either be a definition, a theorem, or a postulate. You all know what definitions are, right? Right, a theorem is something we can prove to be true, and a postulate is something we just know. We're not assuming. We know it's true. We just can't really prove it. Like, for example, we'll learn a postulate that, any segment or angle is congruent to itself, or anything is congruent to itself. Do we know that that's true? That anything must be congruent to itself? Yeah, there's no formal way to prove it, though. Like, any segment or angle has to be congruent to itself, but there's no real formal way to prove that. So that's considered a postulate. That's considered a postulate because we know for a fact that it's true, but there's no formal way to prove that. So every reason will either be a definition, a theorem, or a postulate. And we'll be learning those as each chapter progresses. We'll be adding to our list of theorems and postulates and definitions. All right. So in the past, what happened here? I'm missing a whole page. Oh, that's why. This one went over this one. All right, let's move it up. Let's see if I can just... Oh, goodness. Guess I can just maybe delete that now since we got all our notes there. All right, I think I figured this out. Oh, my goodness. All right. So we are going to learn our first theorem. In the past, because remember theorems are statements that we can prove to be true. In the past, I've written out the proof with you, written out the proof of the theorem. But that's always confused the students because then they think every time they have to do that. So this time I'm not going to write out the proof. We'll verbally talk about it, but then I'll show you how to just use the theorem right away after we prove it. So the theorem tells us if two angles are right angles, then they are congruent. Let's talk about why we would be able to prove this to be true. If two angles are right angles, then they are congruent. Well, what does it mean for two angles to be congruent? By definition. By definition, what do we know? Two angles are congruent if what, Adam?
They have the same like angle measurement.
Good, they have the same measure. So this theorem is saying, well, if two angles are right angles, then they are congruent. Well, what kind of measure do right angles have? 90 degrees. Is that the same? Yeah, so does it make sense to say if two angles are right angles, then they are congruent? Absolutely. All right, so now that we've discussed this theorem and we've verbally proven it to be true, we can now use this theorem at any time on any given day, even in July, okay? We've proven it verbally to be true. Now we can always use it. Let me show you how this would be used in a proof. So proofs generally look like this. You'll see your given. Underneath, you'll see what you want to prove, and then you'll have your diagram off to the side. And I've set up our statement reason proof. So the first piece of given is angle A is a right angle. The second piece of given is angle B is a right angle. What is it that I always want you to do with the given information? Is it Sophie? Mark your diagram. Exactly. We're going to label our diagram with it. So if angle A is a right angle, how do I mark that in my diagram? Somebody knew. Somebody knew. Good. You put a little box in the corner. So I'm going to put a box for angle A. I'm going to put a box for angle B. So now we've gone through our given. We've labeled our diagram. Now, no matter what kind of proof I'm giving you, your very first step will always be to list your given information. So your very first statement will always is always to list your given information. So angle A is a right angle. Angle B is a right angle. Now, I write all the given as one step. In the textbook, what they do is they put each piece of given information in its own step. It doesn't matter. You could put them all in one step or you could put it each in its own step. It doesn't matter. It's whatever you prefer. And now your reason for this is that it was given to us. Because in every problem, what's the only thing we know to be true for certain? Is whatever is given to us. So that's why we're writing it in the proof. Because we only know to be true what is given to us. Now, the whole thing with these proofs is you want to envision you're teaching somebody that only knows, the only knowledge they have is what's written in this proof. If it's not written in the proof, they don't know it to be true. If it's not written in the proof, they do not know it to be true. So now we have angle A is a right angle B is a right angle. We want to prove that angle A is congruent to angle B. Well, didn't we just learn a theorem? What did that theorem tell us? Caleb? Excellent. If two angles are right angles, then they are congruent. Well, isn't that what we want to prove? In our proof, did we tell the reader that we have two right angles? Yeah, we showed that we have two right angles in our proof. So now I could go on and say angle A is congruent to angle B, and the reason is going to be our theorem. If two angles, now look how I'm shortcutting things. I'm using a lot of symbols. If I use symbols, you are allowed to use symbols. Whatever I do, you are allowed to do. If two angles are right angles, then they are congruent. We ready? So that was one theorem. What do you think you're going to have to do with all the theorems we learn? Any guesses? Memorize them. You're going to have to memorize all the theorems that we learn because they're all going to be used throughout the whole year. Okay, let's keep going. Next theorem. All right, we're not proving this. Again, I'm not going to formally prove it, writing it up. We'll verbally discuss what would be the proof of this. So if two angles are straight angles, then they are congruent. Can somebody explain to me why would this be a statement that we can in fact prove? Caleb? Excellent, because straight angles have a measure of 180, and what's the definition of congruent angles? Angles with the same measure. That's why we can prove this theorem to be true. So now that we've verbally proved this theorem to be true, we can now use this theorem moving on forever without ever proving it again. So now we'll go through our given information. Angle ABC is a straight angle. Unfortunately, there's no way to mark straight angles. We just sort of let it be. Angle DEF is a straight angle. Again, we're going to let it be. We want to prove that angle ABC is congruent to angle DEF. We want to prove that these two straight angles are congruent. So, since this is a proof, what's the first thing we always write in our proofs? Jocelyn? The given information. So let's go ahead and do that. Angle ABC is a straight angle. And in the same step, I'm going to say angle DEF is a straight angle. And our reason for writing this is given. Okay, we want to prove these two angles are congruent. Well, these two angles are represented as straight angles. Do we have a theorem that talks about straight angles? Yeah, what does the theorem say? Adam? If two angles are straight angles, then they are congruent. Did we tell the reader that we have two straight angles? Yeah, so we can now use that theorem since we already declared that we have straight angles. So angle ABC is congruent to angle DEF. And our reason is going to be if two angles are straight angles, then they are congruent. Hi, Jonathan.
Can I hang out with you for a minute?
Yeah, of course. Okay. Oops. All right, so now let's practice some proofs. So you do not have to write out the full statement and the full reason every time. We can put S and R. So here we have angle A is a right angle, angle C is a right angle. What do you want? What do I want you to do with that information? Aaron. Excellent. Mark it in your diagram. We mark right angles with little boxes. So a box by angle A, a box by angle C. What's the first thing we write in our proof every time? What's the first thing we write in our proof every time? Olivia. What's given to us? So statement 1, we're going to say angle A is a right angle. Angle C is a right angle. And what's our reason?
It's given.
Given. Excellent. We just write given. Can I now say that angle A is congruent to angle C? Can I now say angle A is congruent to angle C? I see a lot of people nodding their head. You are absolutely correct. Angle A is congruent to angle C. Who knows the reason? Who knows the reason that I would write for this? Looking for a new hand. Looking for a new hand. Noah? Oh, I'm so glad you said that. Okay, so Noah said they have the same measure. Remember, the reader only knows what's written down in the proof. Anywhere in the proof, did we state the measure? No, all we stated were right angles. The reader doesn't know that right angles have the same measure of 90. They don't know that. So we're going to have to think of a different reason here. Bridget?
Every angle in a rectangle is a right angle.
But we don't know that we have a rectangle. It's just a four-sided figure. So we can't write that. You want again? Mariana?
If they're both right angles, then
Good. If two angles are right angles, then they are congruent. Did we state that we have two right angles? So the reader knows we have right angles. And wasn't there a theorem that specifically spoke about two right angles? So if two angles are right angles, they are congruent. That is our reason.
that's crazy. See you at lunch or something.
Bye, Jonathan.
Bye, Jonathan.
All right, we ready for the next one? All right, number 2. We're going to put an S and an R for statements and reasons. The given is diagram as shown. Is there anything to mark for diagram as shown? No. Do we still need to write it in our proof? How many people say yes, we still need to write it in our proof? How many people say no, we do not need to write it in our proof? All right. We still, even though it's useless to us, we still need to write it in our proof because no matter what, our first step is always the given information. So we're going to go ahead and we're going to write diagram as shown. And our reason is given. Now let's look at what we want to prove. We want to prove angle EFG is congruent to angle HFJ. Are they congruent? In your opinion, are they congruent? Yeah, why? Because they are straight angles. Isn't there a theorem about straight angles? What did the theorem say? Somebody knew. What did the theorem say? Look back up. You can find it. What did the theorem say? Vincent, what did the theorem say? You're not Vincent. You are. Colin, what did the theorem say? That two straight angles are congruent. But we have a problem. Can somebody tell me what the problem is here about our proof right now? There is a problem. We cannot state our proof statement at this moment. Olivia? Good. It didn't say it was straight angles. Remember, the reader only knows what's written in the proof. All that's written is diagram as shown. It didn't say that we have straight angles. But do we know that they're straight angles? How do we know that they're straight angles? Emily? Because we can assume straight angles. So we have to write that in our proof. So statement 2, and something else you should know, anything with the same reason can be written as the same statement. So anything with the same reason can be written in the same statement step. So I'm going to say angle EFG equals straight angle. Angle HFJ equals straight angle. And we are going to write assumed. One word, assumed. Now in honors, they put AFD. Does anybody think they know what AFD stands for? Assumed from diagram. AFD means assumed from diagram. You can write assumed, you can write AFD, I don't care. Assumed from diagram. So now that we told the reader that we have two straight angles, now can we say that they're congruent? Yes. Angle EFG is congruent to angle HFJ. And not Chase, not Adam, someone tell me, what is the reason here? What is the reason now that we can say that these two straight angles are congruent? Sophie? Excellent. If two angles are straight angles, then they are congruent. Do we know what time this period ends? Okay, great. All right, next proof. Again, what am I going to do? I'm going to go through my given. I'm going to label my information. Angle RST is 50 degrees. Follow the letters, label your angle. So that's 50 degrees. Angle TSV is 40 degrees. Label our angle. And angle X is a right angle, so I'm going to make a box. I'm going to put an S and an R for statements and reasons. And my very first statement is always, James, the given information. So I'm going to state the given information. So angle RST equals 50 degrees. Angle TSV equals 40 degrees. Angle X equals right angle. And our reason is given. All right, let's look at what we want to prove now. We need to prove that angle RSV, that's this big angle, is congruent to angle X. Well, right now, have we been told anywhere in our proof anything about angle RSV? No, but can we figure how big RSV is? Yeah, how big is angle RSV? Oh, I get a lot of hands. This makes me so happy, Mariana. This is 90 degrees. Do we need to write that in the proof?
Yes.
Absolutely. So I'll show you how we're going to write this. You're going to name the angle. So angle RSV RSV equals 90 degrees. All right, so this is where kids usually start messing up. Your reasons have to be completely generalized, meaning the reason I use for this problem should be able to be used for any problem I give you. So it cannot be specific to this problem, meaning you can't write, well, I added 50 and 40 and that equals 90, because that is very problem specific, right? In this specific problem, you added 50 and 40 and got 90. So we have to be very generalized. It's actually just going to be one word. What did I do to get 90? We added. So it's going to be addition. Exactly. It's going to be addition. Okay, so now let's look at what we want to prove. We want to prove that angle RSV, which in our proof we stated is 90, and angle X are congruent. I'm going to stop and tell you right now, at this point in the proof, I cannot say that they are congruent. At this point right now, I cannot say that they're congruent. Any ideas on why at this point I cannot tell the reader yet that they are congruent? Noah?
We haven't mentioned that angle X is equal to 90 degrees.
Exactly. Right now, they're talking about angles, but talking about them in different formats. Here they said angle X is a right angle. Here they said angle RSV is 90 degrees. Do we know that they're the same? Yes, but the reader only knows what? What's written down. So does the reader know that they're the same? No. So we have one of two options. We can either say that angle RSV is a right angle, or we can say angle X is 90 degrees. I'm going to do the second option. I'm going to show you something different. I'm going to tell you, we're going to write that angle X is 90 degrees. So step number 3, I'm going to say angle X equals 90 degrees. So we were given that it's a right angle, and now we're stating that it's 90 degrees. How do we know that it's 90 degrees? We didn't just make it up. Mariana?
Right angles are equal to 90.
Good. What is that? Well, yes, but like in general, what is that? Right angles have a measure of 90 degrees. What is that? Not an assumption. No, we only assume straight angles. That's a fact. So what is that? Olivia? The what? A postulate? No, a postulate is something we know is true but can't prove it. Isn't this the definition of a right angle? The definition of a right angle is an angle that has an exact measure of 90. That's a definition. Right? Since it's a definition, a right angle has a measure of 90 degrees. What we can do as our reason, since it's a definition, we can say definition of, so def of right angle. Def of right angle. So anything that's a definition, we are allowed to write in our proof, def of whatever the definition is. Anything that's a definition, we can do that. Okay, so now I have angle RSV is 90 degrees and angle X is 90 degrees. Did we show them to be the same? Yeah. So now I can go ahead and say they're congruent. I will tell you, I am not allowed to say if two angles are right angles, then they are congruent. I cannot say that. Why am I not able to say that? Tell them to lift up. Tell them to lift up. Okay.
I
Oh,
went in the middle
Cal.
of class and your door was locked.
It's not locked. You have to lift the handle
Mr.
up.
Benson said I have to come in here.
Really?
Yeah.
That's so nice.
But I have to leave now.
Okay.
Bye.
Bye. All right. So why am I not able to say if two angles are right angles, then they are congruent? Why is that not acceptable here? If two angles are right angles, then they are congruent. Jocelyn?
Because we said they're 90 degrees.
Excellent, because we said they're 90 degrees. So we're going to have to think of a different reason. So we're going to say angle RSV is congruent to angle X. Didn't we show them to have the same measure? And what's the definition of congruent angles? Two angles with the same measure. Isn't that the definition of congruent angles? So here, this is just based on a definition. They're congruent because they have the same measure. So what can I write? Def of congruent. You got it. All right, next one. All right, diagram as shown. Anything to mark for that? No. Do I still need to write it in my proof? Yes. All right, so we need to now prove that angle AGD, which is this yellow angle, congruent to angle EGB, this green angle. Are they congruent? Yeah, why? Emily? They're both straight angles. Has it been told to us in the proof that they're straight angles? No, so what do you think my second step is going to be? Chase?
Write that we assume that they're both straight angles.
Okay, so what is my statement?
Angle
AGD.
is a straight equilateral triangle.
Yep, and angle.
EGB
Yep.
is equilateral triangle.
And do you remember our reason for that?
Assumption.
Assumed. Good. Could you write AFD if you wanted? Yes. All right, now that I declared them both straight angles, I can now say that they are congruent. Angle AGD is congruent to angle EGB. This is not definition of congruency. This is not def of congruent. Can someone tell me why this is not def of congruent as my reason? Mariana?
Because straight angle isn't a measure. It's not giving a number.
Exactly, because we said straight angle. We did not give a number. Excellent. I love how you worded that. Okay, we gave a straight angle. We did not give a measure. So we cannot say def of congruent. What can we say, though? Adam?
Two straight angles are congruent.
I would take it. Two straight angles are congruent. Right? There was a theorem. Do we see why we now have to memorize all our theorems? Because we're going to be using them in the proofs. So the theorem was if two angles are straight angles, then they are congruent. Adam said two straight angles are congruent. I would take it. If two angles are straight angles, then they are congruent. All right, number 5. I want you to try number 5 on your own. There's one little part of it that we haven't done yet in class, but I feel like from the past examples, you can figure it out. So try it, and then we'll go over it as a class. I'm going to be coming to see how you mark up your diagram. I'm going to be walking around to see how you mark up your diagram. just thinking. What are we? Okay, sometimes that's a difference in the subject. So you're gonna write, you're not gonna show the two angles you're adding together, you're gonna just run the final angle. So it's going to be just three letters. Good, and then write the number, so equals. You got it, just like that. So we have label our diagram. So let's go through and label it now. Let me see how you label it. How you will label it. Okay, so first mistake there. So you're now saying angle DBC is 120. That's how you labeled it. You want angle ABC to be 120. So it's going to be a full angle. Now let's look at what we want. We want the angle DBC, which angle is that? Can you find a number for DBC? So we try to find angle What did you do when you had that 100? So don't worry about like what to write down. You just tell me what you do to get them. Minus, right? What's another word for minus? Subtraction. You got it. And just follow that same process. Beautiful. Perfection.
Ran out of room.
Okay.
You
can expand. No. There you go.
Thank you.
All right, let's do this. So what do we have here? We have angle ABD is 20. So that's 20 degrees right there. I saw a lot of people go to mark angle ABC as 120 and put it down here. You can't do that because now that's representing that angle DBC is 120. So we don't want that. So how are we going to do this? I would personally go like this and write 120 to show that whole big angle. Some of you wrote it on the outside, which I'm equally okay with. All right, so that's also fine. Next one, it says angle EFY is 60 and angle XFY is 40. Right, you all know the first thing we have to do is write down our given information. To save time, I'm not going to write it all out. Now, moving forward, we want to show that angle DBC, which is this angle right here, is congruent to angle XFE, that angle right there. Do we have a measure for angle DBC? No, but can we find a measure?
We do angle ABC minus angle ABD to get angle DBC.
And what is it?
It's 100 degrees.
It's 100. We're going to do 120 minus 20. We're not going to write down the angles that we're subtracting. All we do is write down the final angle that we need. So angle DBC equals 100. Erin?
I have a question.
Sure.
Does it matter when we're running it down? Does it matter if you use an additional version?
Nope, doesn't matter. All right, so angle DBC equals 100. One word. What did we do? Justin. Subtraction. You got it. And now we need to show that that's congruent to angle XFE. Well, we don't have a measure for angle XFE right now, but we can get one. James, what is it? Angle XFE equals 100. And what's your reason for that? Addition. Can I now say the two angles are congruent? Yeah, so angle DBC congruent to angle XFE. Who thinks they know the reason for this last one? Caleb. Excellent. Def of congruent. All right. Are we doing this homework? No. All right. You can have that if you want some extra practice when you're studying. These are good problems to look at, but there is no homework tonight. Let me hand back your quizzes.